All right, let's look at the proof of the quotient rule. All right, so quotient rule goes like this: f of x over g of x, and if you take the derivative of that, you get f prime of x times g of x minus f of x g prime of x. Note that this is almost the same as the product rule on top, except for the sign here, and then all over g squared. All right, so let's prove that. All right, so using the definition, we have, so if you have f of x over g of x and take the derivative of this quotient, and the definition is limit as h approaches 0, all right, then we plug in x plus h, so it's going to be f of x plus h over g of x plus h. Minus the original function, which is f of x over g of x, and all over h, right? So what we need to do is we have two fractions. We need to probably find the common denominator and then combine them. Let's do that. So you have a limit as h approaches 0. Alright, so common denominator is usually the easiest one is the product of the denominators. So I'm going to do g of x plus h times g of x. So that's the common denominator. So we need to multiply f of x numerator by g of x. So f of x plus h times g of x. Right, so I'm going to give a little bit of room here, and then here it's going to be minus. Right, so since we multiply g of x by g of x plus h, we're going to have to multiply by the same thing. So you have f of x times g of x plus h. Right, so we have that. All right, actually, I might have to move this guy a little bit. So I'm going to just move it. So here, and I'm going to move it maybe right here. All right, and then all over h. Oops, I forgot to. All right, go back to the pen. All right. All right, so since I know what I'm trying to get, I have to get the f prime, right? Remember that f prime involves f of x plus h minus f of x. So f of x plus h is sitting right here. So what I'm going to do is I'm going to put the minus f of x here, right? But we have to have a g of x too, so I'm going to put the g of x right here, right? Then I'm going to put add that back because this wasn't there, so you can't just subtract anything. So you're gonna have add exactly the same thing back, right? So this is an add and subtract trick. Since we add and subtract the same thing, we are really not doing anything, right? All right. So then we can split this into two parts. So you have a limit as h approaches 0. All right, so here. So what I'm going to do is here, I'm going to just look at the first two terms. And you notice that there are two, there's a common factor. Both of them has g of x there, right? So I'm going to pull those guys out. Maybe put it right here, right? So we have a g of x. All right, then what's left would be, all right, we have f of x plus h from the very first term. So we have that. Maybe I should circle this, right? Then you have a minus f of x, which is exactly what we wanted. All right. All right, then I'm going to change the order of division. So we divide by g of x plus h in the g times g of x and divide by h. I'm going to go ahead and divide by h first. So I'm gonna divide by h first. Then later, I'm going to divide by g of x plus h. and times g of x. It's the same thing, right? I just divide by h first, then after that you do g of x plus h and g of x. All right, so that's the first two. All right, second two, we're going to do what's in common. So I'm going to pull out negative f of x. All right, it is only a positive f of x, so you have to put the negative sign there. So I'm going to pull out the negative f of x. All right, so I'm going to just do this and that one. I have to change that to a negative sign though, right? So we have what's left is g of x plus h from there. And then you have a minus g of x, right? So you have a minus g of x. And then again, I'm going to divide by h first. Then after that, you do g of x plus h times g of x. All right. Then we're almost there, right? We're taking a limit as h approaches 0, right? So we're going to, right, this one is going to 0, right? So you have a g of x times g of x. So maybe I should write that. Right, on the bottom, you have g of x times g of x. So you have a g of x and squared, right? All right, so we're assuming that these functions are continuous because they're supposed to be differentiable. Differentiable implies continuity. All right, so this guy approaches g of x. All right, so you have two of them. All right, then if you take the limit of this quotient here, right, that's exactly the derivative of f. So it's a f prime of x. All right, g of x has nothing to do with h, so it's going to stay the same because it's basically a constant. And f of x is the same way, stays the same. All right, if you look at the limit of this guy is exactly the definition of g prime. So g prime of x. All right, then as you can see magically, we got exactly the same thing as the quotient rule. So this verifies the quotient rule. All right. That's it. I hope that this was clear.